Hi, this video is going to go through question 6 from the A2 November test. In part A, it goes through wants you to give the mechanism for the nitration of benzoic acid, and you also have to show how H2SO4 behaves as a catalyst. So we're going to have 3 steps on this. First off, we'll show how our electrophile is created. We'll have sulfuric acid with our nitric acid is going to form our electrophile plus HSO4 minus plus water. Next up, our benzoic acid is then going to react with that. So we need a curly arrow from the ring to the electrophile. That is going to create an intermediate, and it shows you in the equation that the nitro group is going on to the 3rd carbon. So we need to do intermediate showing that as well. So we'll have bond to a hydrogen and bond to the NO2 and a broken ring with a positive charge in the centre. Then curly arrow to represent the electrons from that bond going back in, and that leaves us with the NO2 attached, our COOH group there, but if electrons have gone from there, that's broken the bond to the hydrogen, which now doesn't have any electrons, so it's H+. In step 3, that H+ is going to join with the HSO4 to form back our H2SO4, and so we reform our catalyst. So 1 mark, 1 mark, 1 mark, 1 mark, 1 mark. In part B, it asks you to explain or state the trend in relative ease of nitration of phenol, benzene and benzoic acid. So you need 2 bits here. Phenol is the most easily nitrated. Benzoic acid is the least. And then we need to apply our knowledge of the bonding in arenes to explain the trend we've just seen. So for this, if we start with phenol, phenol is electron donating, so it's going to donate a pair of electrons that is going to partially delocalize into the pi ring. So with phenol, it's going to increase electron density because it's donating. If we compare that to benzoic acid, this is a carbon bonded to an oxygen here. They're both going to be taking electron density away from the carbon. So you've got a very delta positive carbon here, which is then going to attract electron density from the pi ring. So we call that a withdrawing group. So any mention that the COOH group withdraws electron density. So phenol we've got an increase in electron density. Therefore, ring is more susceptible to attack. Or you could have said for the same mark that the benzoic acid is low in electron density, so is less susceptible to attack. So the 3 marks on this were for saying that on here, lone pair of electrons delocalized into the ring or the pi system. Second mark is for saying COH group withdraws electron density. And the third mark is for saying either increase in electron density of phenol means the ring's more susceptible to attack, or the benzoic acid lower in electron density, so less susceptible to attack. And that's question 6.